Today our topic of discussion is geometric sequences, and normally we do the discussion as a class, but I forgot to record, so I'm just going to go through the notes and talk you through what it is that we did today. So our discussion was geometric sequences. Over the past couple of days, we've learned about arithmetic sequences, and arithmetic sequences are sequences that are created by adding a common difference to each term. A geometric sequence, as you can see, is a sequence created by multiplying by a constant ratio. So arithmetic, you add to get each term, and geometric, you multiply to get each successive term. We went through a few problems, 1, 2, and 3, in which I gave a bunch of sequences, and then we had to determine whether they were geometric or not. And if they were, then what was the common ratio? So let's take a look at question number 1. Question number 1 has 5, 10, 15, 20, 25. And we looked at it and we said, okay, so the difference between each term is 5. And so this is not a geometric sequence because you're adding 5 each time. In fact, this is an arithmetic sequence. Take a look at question number 2. Question number 2, you look at each term in the sequence and we said, okay, so like what's the pattern here? Well, you had to multiply by 3 each time to get each of these terms. And so that is a geometric sequence, and the common ratio is 3. Now, you can get real tricky with these because in the question number 3, you'll see that, okay, so it's like you divide by a half each time, and that's how you get each one of these terms. Well, dividing by 2 is the same thing as multiplying by a half. And so it is a geometric sequence, and the ratio between these terms is a half. And so this one is very tricky. Remember that. If you're thinking that the sequence goes by dividing by 2, dividing by 2 is the same thing as multiplying by a half. Multiplying by a constant ratio is, by definition, a geometric sequence. Now let's take a look at the question number 4. Okay, we only did 5 problems today. Question number 4, given the geometric sequence, right, find the 8th term. Okay, well, here's what you could do. You could literally write out 8 of these terms, but you can see it's starting to get very big very fast. And like, God forbid I had given you like the 15th term of this sequence, like asked for it. I mean, you would have to keep track of all these numbers. And there must be a better way. Or maybe perhaps not better, but faster. There is, in fact. Here's the formula for it. Okay? Any term in this sequence, you can find the 50th term if you really wanted. Any term in this sequence, any nth term you want, is equal to the first term in the sequence times the ratio, the common ratio, raised to the n minus 1 power. Okay, so what does that mean? Well, we asked for the 8th term. The first term in this sequence was 1. The common ratio between all the terms was 5. And plugging in 8 minus 1 gives us 7. Punch that into your calculator, you get that answer. This is the 8th term. Okay. All right. Our final problem of the day. Here we go. Form a sequence that has 3 geometric means between 4 and 324. Okay. Well, just like arithmetic sequences in series, geometric sequences in series have geometric means. They have numbers between terms. That's what a geometric mean is. Okay. So how do we set this up? Well, the first thing we did in class was we drew a picture of the problem. And then we said, okay, so it's like geometric, right? So that means we must be multiplying by a constant ratio each time to get down over here. And if that's the case, then we can probably build some kind of equation to represent what it is that we just drew. Well, 324 then is equal to the first term times r times r times r times r. And r to the r times r times r times r is the same thing as r to the fourth. Divide both sides by 4, you get that 81 equals r to the fourth. And then we did a bunch of things in our calculator. Some people guessed at it. It turns out r is equal to 3. This, by the way, is going to be the topic of discussion for our next unit, which is exponents. But in the meantime, if r equals 3, right, 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. And 108 times 3 is 324. So the three geometric means you're looking for are 12, 36, and 108. And that's it for today. That's all we did because it was a short Friday and it was an easy topic. And some people had some questions on some homework from last night that I went over. And if you have any trouble, just come in and I'll ask. Please remember that you have a calendar quiz that's due on Monday. And we'll see you then. Have a nice weekend.